Good evening, everyone. This is the ninth live discussion session of the NPTEL course Soil Mechanics Geotechnical Engineering 1. This is a pre-point session of the Monday classes, and the topic of today's class is consolidation and time rate of settlement. Now, sorry, a part of this has been already covered in the last class, in the last Monday. I think there is a network issue. I'll just switch on to the yes PowerPoint. Yes, yes. So I believe the net is back. Yes. So this is a continuation of the last session. Okay, we continue the last session. In the last class, we have studied about the compressibility of soil, the basic differences between consolidation and compaction, and some basic concepts of consolidation and few numericals. Today, this class is mainly focused on the uh, theoretical, problems of the concept of consolidation. This chapter has many numericals, basically delving into the depths of the settlement, problems in consolidation. Okay, so without further ado, I'll just start dictating the questions. Whoever will join the meeting, please start writing the questions or take screenshots, whatever is feasible with you. You can do that, and after I dictate the questions, I'll give some time around 15 minutes to solve those questions, and then after that I'll start discussing the solutions with the explanations behind them. Okay, so this is the ninth live session, Soil Mechanics Geotechnical Engineering 1. Then the topic is consolidation and time rate of settlement. I will now start dictating the questions. Okay, all right. I think the PPT is visible and I am audible. So I'll just start. The first question is the first question is the ultimate settlement of soil is a function of the ultimate settlement of soil is a function of the options are coefficient of volume change, increment in effective pressure, thickness of the soil layer, or all of these. I'll repeat the question. The ultimate settlement of soil is a function of the options are coefficient of volume change, increment in effective pressure, thickness of the soil layer, or all of these. Next question. Settlement of a soil layer at any time with respect to the ultimate settlement yields. Settlement of a soil layer at any time with respect to the ultimate settlement yields. The options are coefficient of volume change, degree of consolidation, coefficient of compressibility, or coefficient of permeability. I repeat the question. Settlement of a soil layer at any time with respect to the ultimate settlement yields. Options are coefficient of volume change, degree of consolidation, coefficient of compressibility, coefficient of permeability. Okay. I'll go to the next question now. Yes. Consolidation settlement can be computed by using. Consolidation settlement can be computed by using. The options are coefficient of volume change, voice ratio, both of the above, or none of these. I'll repeat the question. Consolidation settlement can be computed by using. The options are coefficient of volume change, voice ratio, both of the above, or none of these. Okay. Next question. Yes, this is a true or false statement. Final settlement is small in case of pre-consolidated soils as the recompression index is very small compared to compression index. I'll repeat the question once. Final settlement is small in case of pre-consolidated soils as the recompression index is very small compared to the compression index. Is this statement true or false? I'll repeat the question once. Final settlement is small in case of pre-consolidated soils as the decompression index is very small compared to compression index. Is this statement true or false? Next question. Yes, so there are four MCQs and two first statements that are completed right now. I'll now start the numericals. Okay, so there are, I think, yes, there are 12 numericals. Write down the data very carefully. Okay. A fully saturated clay specimen is placed in a consolidometer and 2 kg per centimeter square is applied. There is a pressure is applied. After some time, the pore pressure is found to be 0.60 kg per centimeter square. Find the corresponding value of settlement if the ultimate settlement is going to be 20 millimeter. So the pressure applied has been given. After a certain amount of time, the pore pressure has been given. Now you have to find out the settlement at that time when the pore pressure is 0.6. If it has been said that the ultimate settlement is going to be 20 millimeter. I'll repeat the question. A fully saturated clay specimen is placed in a consolidometer and 2 kg per centimeter square is applied. After some time, the pore pressure is found to be 0.6 kg per centimeter square. Find the corresponding value of settlement if the ultimate settlement is going to be 20 millimeter. Okay, I hope the question was clear. I'll go to the next question now. Yes. A settlement analysis carried out for a proposed structure indicates that 9 centimeter of settlement will occur in 5 years and the final settlement will be 45 centimeter based on double drainage condition. A detailed site investigation indicates that only single drainage occurs. Considering the degree of consolidation to be less than 60 percentage, estimate the settlement at the end of 5 years for the changed condition. For the changed condition. So, in this case, after an initial study, the settlement is given in 5 years and the final settlement has been also given, but the condition estimated was double drainage. After the second study, after a detailed study, it was concluded that only single drainage condition persists in the site, in the structure. So now, for the changed condition, you have to find out the settlement at the end of 5 years considering the degree of consolidation to be less than 60 percentage. Okay. In this case, the final settlement, that is 45 centimeter, okay, that is been proposed irrespective of the drainage condition that we have to assume for the sum. Okay. The initial 9 centimeter settlement for 5 years, that has been proposed for double drainage condition, but the final settlement has been proposed irrespective of the drainage condition. Now the final settlement for that, even if it is single drainage or double drainage, the final settlement can be same depending upon the number of years it takes for settling down, for the settlement to occur. Okay. I'll repeat the question once. A settlement analysis carried out for a proposed structure indicates that 9 centimeter of settlement will occur in 5 years and the final settlement will be 45 centimeter based on double drainage condition. A detailed site investigation indicates that only single drainage occurs. Considering the degree of consolidation to be less than 60%, estimates the settlement at the end of 5 years for the changed condition. I hope the question was clear. I'll go to the next question. Yes. A clay layer 8 meter thick is subjected to a pressure of 70 kilonewton per meter square. If the layer has double drainage and undergoes 50% consolidation, for which the time factor Tv equal to 0.196 in 1 year, determine the coefficient of consolidation. If the coefficient of permeability is 0.040 meter per year, determine the settlement in 1 year. Take the unit weight of water as 9.81 kilonewton per meter cube. I'll repeat the question. A clay layer 8 meter thick is subjected to a pressure of 70 kilonewton per meter square. If the layer has double drainage and undergoes 50% consolidation, Tv equal to 0.196 in 1 year, determine the coefficient of consolidation. If the coefficient of permeability is 0.040 meter per year, determine the settlement in 1 year. Take the unit weight of water as 9.81 kilonewton per meter cube. I hope the question was clear. I'll go to the next question. Those who have joined now, please write down the questions, okay, or take a screenshot, whatever is feasible. I'll give you time to solve these questions and then I'll discuss them. Okay. Okay. The question is, a soft, normally consolidated clay layer is 20 meter thick with a moisture content of 45 percentage. The clay has a saturated unit weight of 20 kilonewton per meter cube, a particle specific gravity of 0.27, and a liquid limit of 60 percentage. Liquid limit of 60 percentage. A foundation load will subject the center of the layer to a vertical stress increase of 10 kilopascal. Groundwater level is at the surface of the clay layer. Estimate number 1, the initial and final effective stresses at the center of the layer. Initial and final means before the application of the foundation load and after the application of the foundation load. Initial and final stresses, effective stresses at the center of the layer. Number 2, the approximate value of the compression index. And number 3, the consolidation settlement of a foundation above the layer. For this, take the unit weight of water as 10 kilonewton per meter cube. Please write down the data very carefully. I'll repeat the question once. A soft, normally consolidated clay layer is 20 meter thick with a moisture content of 45 percentage. The clay has a saturated unit weight of 20 kilonewton per meter cube and a particle specific gravity of 2.7 and liquid limit of 60 percentage. A foundation load will subject the center of the layer to a vertical stress increase of 10 kilopascal. The groundwater level is at the surface of the clay layer. Estimate number 1, the initial and final effective stresses at the center of the layer. Number 2, the approximate value of the compression index. And number 3, the consolidation settlement of a foundation above the layer. Take unit weight of water as 10 kilonewton per meter cube. Okay. Next question. Yes. A 20-meter thick clay layer is sandwiched between a silty sand layer and a gravelly sand layer and experiences 30 millimeter settlement in 2 years. If the coefficient of consolidation of the layer is 0.003 centimeter square per second, calculate the extra time required for the soil to achieve a total of 50 mm settlement. I'll repeat the question. A 20 mm thick clay layer is sandwiched between a silty sand layer and a gravelly sand layer and experiences 30 mm settlement in 2 years. If the coefficient of consolidation of the layer is 0.003 centimeter square per second, calculate the extra time required for the soil to achieve a total of 50 mm settlement. Okay, I hope the question was clear. I'll go to the next question. Yes. The average effective overburden stress on 10-meter thick homogeneous saturated clay layer is 150 kilopascal. Consolidation test on an undisturbed soil sample taken from the clay layer showed that the void ratio decreased from 0.6 to 0.5 by stress increment from 100 kilopascal to 300 kilopascal. Calculate number 1, the initial void ratio of the clay layer. Number 2, the total consolidation settlement of the clay layer due to construction of a structure imposing an additional stress intensity of 200 kilopascal. I'll repeat the question. The average effective overburden stress on 10-meter thick homogeneous saturated clay layer is 150 kilopascal. Consolidation test on an undisturbed soil sample taken from the clay layer showed that the void ratio decreased from 0.6 to 0.5 by stress increment from 100 kilopascal to 300 kilopascal. Calculate number 1, the initial void ratio of the clay layer. Number 2, the total consolidation settlement of the clay layer due to construction of a structure imposing an additional stress intensity of 200 kilopascal. Okay, I hope the question was clear. I'll go to the next question now. Yes. At a given site A, having a clay layer 8 meter thick with single drainage, a uniform fill that was constructed resulted in a settlement of 5 centimeter in 1 year, corresponding to 50% average degree of consolidation. It was found that at a neighboring site B, the same type of soil exists, but the thickness is 16 meter. How long will it take for 50% consolidation to occur, and what will be the magnitude of settlement if a fill of the same magnitude as at site A was to be constructed at site B? I'll repeat the question once. At a given site A, having a clay layer 8 meter thick with a single drainage, a uniform fill that was constructed resulted in a settlement of 5 centimeter in 1 year, corresponding to 50% average degree of consolidation. It was found that at a neighboring site B, the same type of soil exists, but the thickness is 16 meter. How long will it take for 50% consolidation to occur, and what will be the magnitude of settlement if a fill of the same magnitude at site A was to be constructed at site B? Now the question was clear. We go to the next question. A layer of normally consolidated saturated clay of 1 meter thickness is subjected to one-dimensional consolidation under a pressure increment of 20 kilopascal. The soil has a specific gravity of 2.7, natural moisture content 45%, compression index of 0.45 and recompression index of 0.05. Sorry. And the initial average effective stress within the layer is 100 kilopascal. Determine the primary consolidation settlement of the soil layer. So the things given in this question are the thickness of the layer, the pressure increment, the specific gravity, the moisture content, the compression index, and the recompression index, and also the initial effective stress is 100 kilopascal. To find out the primary consolidation settlement of the soil layer. Please keep in mind the compression index and the recompression index both are given over here. The compression index and the recompression index. I repeat the question. A layer of normally consolidated saturated clay of 1 meter thickness is subjected to one-dimensional consolidation under a pressure increment of 20 kilopascal. The soil has specific gravity of 2.7, natural moisture content of 45%, compression index of 0.45 and decompression index of 0.05. The initial average effective stress within the layer is 100 kilopascal. Determine the primary consolidation settlement of the soil layer. Okay. Next question. A 4-meter thick normally consolidated clay has an average void ratio of 1.3. Its compression index is 0.6 and coefficient of consolidation is 1 meter square per year. If the increase in vertical pressure due to foundation load on the clay layer is equal to the existing effective overburden pressure, calculate the settlement of the clay layer. I'll repeat the question. A 4-meter thick normally consolidated clay has an average void ratio of 0.3. Void ratio of 1.3. Its compression index is 0.6. Coefficient of consolidation is 1 meter square per year. If the increase in vertical pressure due to foundation load on the clay layer is equal to the existing effective overburden pressure. Mind this statement very carefully. The increase in vertical pressure due to foundation load on the clay layer is equal to the existing effective overburden pressure. For this case, calculate the settlement of the clay layer. Okay. Next question. In a consolidation test, the void ratio of the specimen, which was 1.068 under the effective pressure of 214 kN per meter square, changed to 0.994 when the pressure was increased to 429 kN per meter square. Calculate the coefficient of compressibility, compression index, and the coefficient of volume compressibility. Find the settlement of foundation resting on the above soil if the thickness of the layer is 8 meter and the increase in pressure is 10 kN per meter square. So for two cases of the effective pressure, two void ratio values have been given to find out the coefficient of compressibility, compression index, coefficient of volume compressibility, and then find out the settlement of the foundation if the thickness of the layer is 8 and the actual increase in pressure is 10 kilonewton per meter square. I'll repeat the question. In a consolidation test, the void ratio of the specimen, which was 1.068 under the effective pressure of 214 kilonewton per meter square, changed to 0.994 when the pressure was increased to 429 kilonewton per meter square. Calculate the coefficient of compressibility, compression index, and the coefficient of volume compressibility. Find the settlement of foundation resting on the above soil if the thickness of the layer is 8 meter and the increase in pressure is 10 kilonewton per meter square. Okay, I hope the question was clear. Go to the next question. Okay, a normally consolidated clay settled, okay, this twice given, settled by 2 meter when the effective stress was increased from 100 kilopascal to 200 kilopascal. Calculate the settlement when the effective stress is increased to 400 kilopascal and 800 kilopascal. So the initial is 100. When it was increased to 200, then the settlement was 2 centimeter. So if the same effective stress was increased to 400 kilopascal, what will be the settlement? And if the same effective stress was increased to 800 kilopascal, what will be the settlement? I'll repeat the question. A normally consolidated clay settled by 2 centimeter when the effective stress was increased from 100 kilopascal to 200 kilopascal. Calculate the settlement when the effective stress is increased to 400 kilopascal and 800 kilopascal. Okay, I'll go to the next question. I think that is the last question. Yes. A saturated soil has a compression index of 0.28. The void ratio at a stress of 12 kilonewton per meter square is 2.05 and its permeability is 35 into 10 to the power minus 7 millimeter per second. Calculate number 1 the change in void ratio if the stress is increased to 21.6 kilonewton per meter square, and number 2 the settlement in 1 the soil is 6 meter thick. So here the compression index, the void ratio at a particular stress, and the permeability is given. If the stress is increased to 21.6, what will be the change in the void ratio? Okay, change in the void ratio. And what will be the settlement in that case if the soil is actually 6 meter thick? I'll repeat the question. A saturated soil has a compression index of 0.28. The void ratio at a stress of 12 kilonewton per meter square is 2.05 and its permeability is 35 into 10 to the power minus 7 mm per second. Calculate number 1, the change in void ratio, the stress is increased to 21.6 kilonewton per meter square, and number 2, the settlement in 1 if the soil is 6 meter thick. So these are the questions. I'll give you some time, 15 minutes. After that, I'll start discussing the solution to these questions. Okay. Okay, sorry for the delay. I hope those who have joined they've completed the sums. I'll now straight away start with the discussion part. So the first question was the ultimate settlement of soil is a function of. Any answer? Okay, looks like some of you have left the meeting. Okay, fine. Okay, I'll just straight away discuss the solutions. Okay. Ultimate settlement of soil is a function of the formula for ultimate settlement of soil. If it is suppose del H F means the final settlement, the formula is the product of MV. There is the coefficient of volume change, then increment in effective pressure, and the initial thickness of the soil layer. So 3 upon the 3. So it is a function of all these three: coefficient of volume change, increment in effective pressure, and thickness of the soil layer. So all of these, the fourth option is the right option. All of these. Okay. Next question. Settlement of a soil layer at any time with respect to the ultimate settlement yields. Okay. So settlement, if it is suppose rho with respect to the ultimate settlement, this is the rho f. If we describe this as percentage, then this is the value we get as U, that is the degree of consolidation. So settlement of a soil layer with respect to the ultimate settlement gives us the value of the degree of consolidation U. So the second option is the right option. It is the degree of consolidation. Okay. Next question. Yes. Consolidation settlement can be computed by using. It can be computed by using both, as I've said in the previous, you know, question, the first question. The settlement, ultimate settlement is a function of the coefficient of volume change. The coefficient of volume change is obviously another one, that is the change in thickness or the settlement. The ratio of that to the thickness is equal to the change in void ratio divided by 1 plus the initial void ratio. 1 plus the initial void ratio. Okay. So it depends upon both of these parameters. So consolidation settlement can be computed by using coefficient of volume change and void ratio. So both of the above is the correct answer. Both of the above is the correct answer. Okay. Now, next question. Final settlement is very small in the case of pre-consolidated soils. Yes, for pre-consolidated soils, we have the term called recompression index or swelling index, which is approximately, the swelling index is approximately 1/5 to 1/10 of the value of the compression index. Since this is very less, and we know the settlement, that is del H is directly proportional to the value of the compression index Cc or Cs or swelling index. So if Cs is low than Cc, then this settlement in the case of pre-consolidated soils will be less, very small, and that is primarily because of the low values of the recompression index or the swelling index. It is lower than that of the compression index. Okay, so this is a true statement. Final settlement is small in the case of pre-consolidated soils as the recompression index is very small compared to the compression index. So this is a true statement. Okay. Okay. Next question. A fully saturated clay specimen is placed in a consolidometer and 2 kg per centimeter square is applied. After some time, the pore pressure is found to be 0.6 kg per centimeter square. Find the corresponding value of settlement. The ultimate settlement is going to be 20 millimeter. Now, you have to understand that if the pressure applied is 2, then for final settlement, there will be no pore pressure. So the effective pressure will be 2 minus 0, that is equal to 2 kg per centimeter square. At any time t, if we say that the pore pressure is 0.6, so the effective pressure is 2 minus 0.6, that is equals to 1.4 kg per centimeter square. Okay. Now, the settlement at any time t with respect to the final settlement is also the ratio between the effective stress at that particular time t with respect to the final value of the effective stress. A similar sum have been done in the previous class on Monday, in the previous class. So now what we are supposed to find out, we are supposed to find out the settlement at time t. Time t means when the pore pressure is 0.6. So rho t, value of rho t will be equals to how much? Will be equals to rho f into sigma t by sigma f. That will be equal to what is sigma, what is rho f? Rho f is 20 into sigma t 1.4 divided by sigma f is 2. That will give us how much? It will give us 14 millimeter. 14 millimeter. Okay. Degree of consolidation or effective stress. Degree of consolidation is also the ratio of effective stress at time t to the final effective stress when the pore pressure is 0. So equating those two, we can find out the settlement at any particular time t when the pore pressure is given. Here the given pore pressure is 0.6, so we have found out the settlement at the time when the pore pressure is 0.6, that is equals to 14 millimeter. Okay, is equals to 14 millimeter. I hope the sum was clear, the solution is clear. Next question. Yes. So in this question, first of all, we need to find out that what is the degree of consolidation calculated or estimated from this particular assumption that there is double drainage. So rho is 9, rho f is 45, so we get a value of 20%, for which Now this is 20 percentage. TB, we know TB 20% equals to time factor CV into T divided by, for double drainage here it will be H by 2 whole square. H by 2 whole square. Okay, H by 2 whole square. Now how do we calculate the next part? That is a single drainage. For this, we'll do one thing. We'll from here find out the value of CV by H square. T we have 5 years, and TB, how will you find TB? TB equals to pi by 4. That is the equation of the, just a moment, I'll just write down the actual equation. Yes, pi by 4 into U square. U in percentage is 20 percentage. Okay, so I'll just solve this once to find out the value of CV by H square. Okay, CV by H square is 20%. So 20 by 100, U by 100 whole square is in fraction. So 0.2, U is in 0.2 into pi divided by 4. So TV divided by T divided by 5 divided by 4. Yes, the value in terms of years we get as 1.57. Just a moment. Yes, 1.57 into 10 to the power minus 3. Now I have mentioned previously that 40 centimeter is the ultimate settlement, and that has nothing to do with single drainage or double drainage. Okay, with single drainage or double drainage. Now in this case, for the single drainage, what do we know? We know that TB equal to CV into T. CV is the coefficient of consolidation divided by H square. Okay. Now this is equals to what? This is equals to also, if it is single drainage, obviously the settlement will be less than 20%. So it will follow the same formula as the previous one, pi by 4 U square. Pi by 4 U square. Now we have the value of CV by H square as this 1.57 10 to the power minus 3. We have the value of T as 5 years. From here we get the value of U, that is the degree of consolidation, to be equals to 10 percentage. To be equals to 10 percentage. From here we see that rho by rho F equals to 10 by 100 is 0.1, or rho equals to actual for single drainage using CVT by H square, rho equals to how much? 0.1 into rho F. What is rho F? Rho F is 45 centimeter. So this will give us a value of 4.5 centimeter. Okay. So first find out the value of degree of consolidation. Next we find out the value of CV by H square using the time factor formula for double drainage. Put the same thing for the single drainage and equate that with pi by 4 U square, the basic formula of TV and U. You get the new or the modified corrected value of degree of consolidation as 10 percentage. Using that and the final settlement of 40 centimeter, find out the actual settlement after 5 years. Okay. I hope the sum was clear. I'll go to the next question. Yes. Okay. A clay layer 8 meter thick subject to the pressure of, okay, yes. So here we have many parameters given. Okay. Determine the coefficient of consolidation, that is CV. So again here it has been mentioned double drainage. So we know time factor TV equals to CVT by H by 2 whole square. From here CV, the value of CV we get, time factor is 0.196. Okay, has been said as 1 year, the time is 1 year, and H, H is 8, H is 8, isn't it? Yes. So H by 2 whole square. So we get the value of CV as, putting all the values, we get the value of CV as 3.136 meter square per year. This is the value of coefficient of consolidation. Now find the settlement in 1 year. Find the settlement in 1 year. It has been said that 50% consolidation occurs in 1 year. Okay, let us use the coefficient of probability in this case and find out the value of M, because if we find out the ultimate settlement, then we can half it to find out the 50% consolidation. So MV, how to find out the coefficient of volume change? The formula is K divided by CV gamma W. Now K is given as 0.04, CV is obtained as 3.136, and gamma W has been told to be taken as 9.81. So putting all the values, we get the value of MV as 1.3 into 10 to the power minus 3 meter square per kilonewton. Meter square per kilonewton. This is the value of MB. Now the final settlement or the ultimate settlement, the formula is MV del sigma into H. MV del sigma into H. Now we have MV. Now what is the value of del sigma? A clay layer subjected to a pressure of 70. That is the pressure increment. There is a pressure increment, so del sigma is 70. Okay, del sigma is 70. What is the value of H? H is 8 meters. So we get the ultimate settlement to be equals to 0.728. Here it is not mentioned the increment in pressure. So the initial pressure we'll consider that the pressure was actually 0. It was subjected to a pressure of 70. That means the del sigma value is 70. Okay, so the ultimate settlement is 0.728 meter. Now it has been said that it undergoes 50% consolidation in 1 year. That means half of the settlement is occurring in 1 year. Okay, so rho in 1 year will be how much? Will be half of this 0.728, 50%, that is 0.364 meter. 0.364 meter is the answer. Okay, I hope it was clear. Next question. Yes, here in this question you are first told to find out the initial and final effective stress. So for the initial effective stress, we know that initial effective stress equals to gamma submerged into H. What is gamma submerged? Gamma sat minus gamma W. Gamma sat is 20 and gamma W is 10 into H. What is H? 10. So it gives us the value of 100 kilonewton per meter square. What is the final? Initial plus change. What is the change in effective pressure is? It is 10 kilopascal del sigma. Okay. So del sigma dash equals to 10 kilopascal. So now sigma dash equals to 110 kilopascal, isn't it? 110 kilonewton per meter square or kilopascal, whatever you can write. Okay, so the first part is over. The second part is the value of the compression index. Okay, so we have the formula Cc equal to 0.0 009 liquid limit minus 10. What is liquid limit is 60%, 60 minus 10 equals to 50, and the value is 0.45. 0.45 is the value of the compression index. Now we have to find out the consolidation settlement of the foundation above the layer. Above the layer, we have to take the consolidation settlement of the whole layer. Just remember, in the first case, in the first scenario, we have taken the value of H as 10. Why? The thickness of the layer was 20, but we have to find out the initial and effective stresses at the center of the layer. At the center. So, at the center, the depth is 10. So, we have taken H equals to 10. But in the third case, in this case, we are asked to find the settlement of the foundation above the layer. So the entire settlement of the layer will be considered to find out the settlement of the foundation. Okay. So the formula for this is del H, that is the consolidation settlement is equals to CC
1 plus E0, 1 plus E0, H0, that is the initial height, log to the base 10, initial effective pressure plus the change in effective pressure divided by initial effective pressure. Okay, just a moment.
Hello, am I audible? Okay. So yes, this is the formula, sigma 0 dash plus del sigma dash by sigma 0. Now we put all the values. Cc equals 0.45. E0, what is the value of E0? Now for the value of E0, which is not even given in this question, we have to find out the initial void ratio. What is the initial void ratio? Wg by S. Here saturation is 1. So we will take W sat, that is the saturation moisture content, into G. G is 2.7. The moisture content is 45%, 0.45. The value is approximately 1.215. So E0 is 1.215, H0 is 20, the initial effective stress is 100, the change in effective stress is 10. So putting all these values, we get the value of the settlement to be almost equal to 16.82. 16.82 centimeters. Okay, 16.82 centimeters. I hope it was clear. Next question. Yes, so in this case, the thick clay layer is sandwiched between a silty sand and gravelly sand, which means double drainage. Which means double drainage. Okay, so again, the formula for the time factor we will be using to find out the value of time factor. Okay, here it is Cv into T divided by H by 2 whole square. What is Cv? 0.03. Cv is 0.03. It is 2 years. Convert the years into seconds. 2 years into 2 into 365 into 86400 divided by 20 by 210 into 100 in centimeters. We get a value of 0.1892. 1892. First of all, we find out the time factor. Now we equate this time factor with the equation pi by 4 u square. Pi by 4 u square, assuming that it is less than 60%. Pi by 4 u square. Now we get the value of u to be, in this case, 0.4908. 0.4908. Okay. Now the settlement, this is in 2 years. So if u equals to settlement by ultimate settlement, okay, then we get the ultimate settlement to be as settlement by u, that is 30 is the settlement in this case in 2 years, divided by the obtained value of u. What do we get? We get a value of 61.12 millimeter. 61.12 millimeter. Now, if this is rho f, then for 50 mm settlement, for rho equals to 50, what is the value of u then? 50 divided by 61.12, isn't it? 50 divided by 61.12, and that gives a u of approximately 81.8 percentage. 81.8 percentage. Obviously, this will be into 100. Now, for value of u more than 60, we use a formula that is in the above. TB equals to 1.7813 minus 0.9332 log to the base 10, log to the base 10, 100 minus u, 100 minus u. So using this formula, we get the value of TB, the new value of TB for 50 mm settlement to be equal to 0.6054. Now rearranging the first formula to find the value of T. T equals to how much? T will be equals to time factor into H by 2 whole square divided by CV. We get a time of approximately 6.4 years. 6.4 years. Now it has been said calculate the extra time required. So after 2 years, how much time will be required? Del T 6.4 minus 2, that is 4.4 years. 4.4 years will be required for the soil to achieve a total of 50 mm settlement. Okay. I hope this was clear. Next question. Yes. In this sum, we are going to find out at first the initial void ratio. Just a moment. Yes, the initial void ratio. For that, we'll first of all find out the compression index. Now, Cc equals to del E divided by log to the base 10 sigma 2 by sigma 1. Okay. Now, what is del E? Change in void ratio. Change in void ratio 0.6 minus 0.5 is 0.1. Log to the base 10 sigma 2 is 300. Sigma 1 is 100. Putting all the values, we get a value of compression index of 0.21. Now for the next case, in this value, okay, I'll just write it over here. This is again equals to del sigma. What is del sigma? Del sigma is not del sigma, sorry, del E. Okay, del E. Now the initial overburden stress is average overburden stress is 150. Okay, overburden stress is 150. Yes. So it has been said. Okay, I'll just write it to make you understand fully. It has been said that this is the value of P. This is the value of sigma. So when the value of sigma is 150, this is the average overburden stress. Then the value of E is equals to E0. E is equals to E0. Now for 100 we know that it was equal to 0.6. So Cc is also equal to this formula where we can write it like this. For E0 it will be obviously less than 0.6. So 0.6 minus E0 divided by log to the base 10. What is del sigma 2 over here? This is del E. Del sigma 2 is how much? This is 150, right? 150 by 100. So I'll just solve this now, and the value of Cc is equals to again 0.21. 0.21. Okay. So log 150 log of answer, this is this, into 0.21, 0.6 minus answer. Yes. So from here we get the value of E0, initial void ratio, to be equal to approximately 0.563. 0.563. Okay. Now the consolidation settlement. Again the same formula which we have used in the previous sum. Del H equals to Cc by 1 plus E0 into H, original height, log to the base 10, sigma 2 final by sigma 1. Okay. Now sigma 2 over here, sigma 2 is equals to 150 plus additional stress intensity of 200 kilopascal plus 200, and sigma 1 is equals to this is sigma 2 dash. I'll let sigma 2 dash and I'll let sigma 1 dash. Sigma 1 dash is equals to 150 initial. So putting all these values, we get the value of del H as approximately equivalent to 0.5 meter. 0.5 meter. Okay. So first of all, using the value of
index, we find the initial void ratio of the soil, and then using the compression index and initial void ratio, the formula is Cc by 1 plus E0 H log to the base 10 sigma 2 by sigma 1. We find the value of the consolidation settlement. Okay. Okay. Next question. Okay. Now here it has been said 50% consolidation in this sum. This is constant. 50% consolidation. Okay. So for the same, for u equals to constant, we know from the formula time taken is directly proportional to the square root of the thickness. That is T1 by T2 is equal to H1 by H2 whole square. Now we know the value of T1, or if you can write it like this, A TA by TB. Just write like this, TA by TB is equals to HA divided by HB whole square. We are told to find out what? The value of TB. How long will it take for the consolidation to occur at the side B? Is equals to TA into TB equals to TA into HB TA equals to HB divided by HA whole square. HB by HA whole square. And now HB is how much? HB is 16, HA is 8, 4. Okay. 4, TA is 1 year. So 4 into 1, it becomes 4 years. TB is 4 years. It will take 4 years to attain the 50% consolidation. And now the settlement. So we know del H is equal to MV del sigma into H0. So we can write like this. Also in this case, if del H equals to rho, okay, I'll let del H only, del H at A divided by del H at B, this is equals to HA divided by HB, because it is directly proportional to the thickness of the soil. Okay, now we have to find out del HB. del HB. That will be equals to how much? Del HA, that is the settlement at A, into HB by HA will be equals to HB by HA. Okay. Am I audible? Hello? Hello? Okay. So there's a problem in the audio connectivity. I'll just use the. Okay. So here in this case, just a moment.
Yes, yes. Am I audible? Yes. Okay. Thanks. So yes. So in this case, it will be HB by HA. So the main concept is the settlement is directly proportional to the thickness of the soil layer. So del HA. What is the value of del HA? It is 5 centimeter settlement in 1 year. So del HA is 5. HB is 16. HA is 8. We get the value of 10 centimeter. 10 centimeter. So at the site B, it will take 4 years to attain 50% consolidation to occur, and when it will do so, it will have 10 centimeter settlement after the consolidation takes place. Okay. Next question. Primary consolidation settlement. Okay. So in this case, first of all, we don't have the value of void ratio. So for that, initial void ratio equals to Wg divided by S. So in saturated, so AC equals to 1. The moisture content of 45%, G is 2.7. We have again E0 equals to 1.215. Okay, E0 equals to 1.215. Now we have the value of Cc given over here. Cc given over here. So what are we asked? Layer of the soil specific gravity. The initial average effective stress is given the primary consolidation settlement. So the formula is del H consolidation settlement equals to Cc by 1 plus E0 H log to the base 10 sigma initial plus del sigma divided by sigma initial, or sigma final by sigma initial. Okay. So the initial stress is 100. The initial stress is 100. The increment in stress is 20. So it will be over here 120 by 100. Okay, 120 by 100. The height is 1 meter. The height is 1 meter. The value of Cc, what is the value of Cc? The compression index is 0.45. It is not being said over here it is a remolded soil or pre-consolidated soil. So this decompression index will not be of any use. We will only be using the compression index. So using Cc equal to 0.45, E0 equals to 1.215, H is equals to 1 meter, del sigma 20 and sigma equals to 100. We obtain a value of consolidation settlement of the soil layer to be approximately equal to 16.08 approximately. Might change depending upon the calculations, but approximately 16.08 millimeter. Okay, it's a simple sum. I'll go to the next question. Yes. Here the void ratio has been given, the Cc compression index is given, coefficient of consolidation Cb has also been given. What are we asked to find out? Increase in vertical load due to foundation. Okay. So if the initial it is sigma, del sigma increase in vertical pressure due to foundation of the load is equal to the existing overall pressure. So del sigma equal to sigma over here. Del sigma equal to sigma. Now the value of settlement we know Cc given as 0.6 by 1 plus E0. E0 is given as 1.3 into H 4 meter log to the base 10 sigma plus del sigma divided by sigma. Now del sigma equal to sigma. Okay, so this becomes 2 sigma by sigma, that is 2 log 2. And now putting all the values, Cc equal to 0.6, E0 equals to 1.3. Yes, height is 4, del sigma equal to sigma. We get a value of approximately 314 millimeter. So this is the simple question. The only trick is in this part that the effective overburden pressure, the increase in overburden pressure is equal to the existing overburden pressure. Okay. The value of coefficient of consolidation also over here is of no use. Got it? Next question. Yes. So here we have to find out many parameters. The first of all is the coefficient of compressibility. That is the value of AV, coefficient of compressibility. That is change in void ratio by change in effective pressure. E0 minus E divided by sigma minus sigma 0. Okay. E0 is 1.068, E is 0.994, sigma 0 is 214 and sigma equals to 429. Putting all the values, we get the value of AV to be approximately equal to 3.44 into 10 to the power minus 4. The unit is meter square per kilonewton. Okay, this is the first part. The second part is the compression index, Cc. Cc del sigma, sorry, del E divided by log to the base 10 final pressure divided by initial pressure. Okay, now del E is again this one E0 minus E and this sigma hash is 429. This is sigma, I'll add the sigma by sigma 0. Sigma is 429, sigma 0 is how much? Sigma 0 is 214. We get a value of approximately 0.245. Okay. Next is the coefficient of volume compressibility, MV. MV. Okay. CC divided by, sorry, not CC. MV equals to coefficient of compressibility AV divided by 1 plus E0. Now, AV equals to 3.44 into 10 to the power minus 4. E0 equal to 1.068. We get a value of 1.664 approximately into 10 to the power minus 4 meter square per kilonewton. Okay. Now the settlement in this question we are asked to find out settlement due to increasing pressure of 10 kilonewton per meter square. Now you have to understand that we cannot use the formula settlement equals to mv del sigma h, even though we have del sigma. We have del sigma is equals to 10. We have height of the sample given as soil layer given as 8, but we can't use because the formula, that is rho f, the formula rho f equals to mv del sigma h is used for ultimate settlement. But we don't know that the increasing pressure of 10 kN per meter square will give us the ultimate settlement or not. So we cannot use this formula. We have to use the basic settlement formula, del H equal to Cc by 1 plus E0 H into log to the base 10 sigma plus del sigma divided by sigma. Okay, here we write sigma 0 because we use 214 as the initial one, and del sigma is equal to 10. Del sigma is 10. We get a value of approximately equals to 18.8 millimeter. Okay, 18.8 millimeter, and thus we have found out the settlement of the foundation. I hope it was clear. Next question. Normally consolidated clay settles by 2 centimeter. Effective stress increase from 100 to 200. We again write the basic formula over here. Del H equals to Cc divided by 1 plus E0 into H into H log to the base 10 sigma final by sigma initial. Now we see over here that the height is not given. The height is not given. The value of Cc is not given. The value of E0 is not given. So we will take this entire thing as K. We will write this formula as K into log to the base 10 sigma final divided by sigma initial. Now what is the value of K over here? For sigma final 200, sigma initial as 100, and the value of del H settlement as 2 centimeter, the value of K will obtain like this. K equals to del H means del H, or the formula is here, I'll just write 2 over here. 2 divided by log to the base 10, 200 by 100. 200 by 100. That gives a value of approximately 6.644. 6.644. Now for the first case, when the pressure has been increased to 400, then H 400. Okay. Then what we'll write? K into log to the base 10 increment to 400 divided by the initial was 100. The value of K we know. We get the value approximately 4 centimeter. Again for the next one, del H 800, we'll write it as like this, K into log to the base 10. Okay, the final was 800, the initial was 100. We get a value approximately 6 centimeter. Okay, I'll just do one of these parts. Log of 8 into 6.64. Yes, 6 centimeter. Okay, so the value of K has been obtained in centimeter only, and we get all the other values in terms of centimeters by putting that particular value of K and the corresponding value of the final pressures, final stresses. Okay, I hope this was clear. Next question. Yes, calculate the change in void ratio. So the formula for Cc is change in void ratio divided by log to the base 10 sigma final by sigma initial. From here, the change in void ratio we can find out equals to Cc into log to the base 10 sigma final divided by sigma initial. Okay. Now, okay. Now The value of CC, what is the value of CC? Is 0.28. Sigma final is 21.6 and sigma initial is how much? It is the value of 12 kilonewton per meter square. We get a value of approximately 0.0715. 0.0715, the value of the change in the void ratio. Okay. Now we have to find out for this case the settlement. We know that settlement del h divided by the original height equals to change in void ratio by 1 plus original void ratio. From this, del h equals to original thickness into change in void ratio by 1 divided by 1 plus initial void ratio. Initial void ratio is how much? Initial void ratio, it is given as 2.05. The initial stress of 12 kilonewton per meter square. We consider 12 as the initial one. We get 2.05. So we put everything in this formula. The value of H is 6, del E is 0.0715 and E0 is 2.05. We get a value of 0.141 meters. Why meter? Because the value of H is taken as meter, 6 meters. So this is the settlement for the increment in stress to 21.6 kilonewton per meter square, for which the change in void ratio is 0.0715. Okay, then let me just solve it once. 0.0715 into 6 divided by 3.05. Yes, 0.1406, 0.141. Okay, I hope the solutions were clear. Those who have joined, thank you for joining the class. The next class on Monday has been preponed to this Saturday, and the next to next class also has been postponed to the next Saturday. So I think the next class is going to be on the 5th of October. So this is the ninth session. 3 sessions are left, which will be held on the 5th, the 7th, and the 14th of October, respectively. Okay. Thank you so much for attending the class.